How are you guys? Today we'll be look at types of fluids. It's still properties, we're still under properties of fluids. Fluid mechanics N5. Let's check. I want us to discuss about types of fluids. Types of fluids. Types of fluids. What are number one? I want us to know we have what we call ideal fluid. We have ideal fluid. Second, we have real fluid. Okay, here we have again Newtonian fluid. Number four, we have non-Newtonian fluid. Fifth one is not necessary. N5 will never. I will just write it, but let us not define it, but I will just state it because they are classified as 5. There are 5 types. There are 5 types of fluid. But fifth one is not necessary. Ideal plastic fluid. As I said, N5, let us not focus to this one, but I'm just writing so that you will see it's ideal plastic fluid. Let me just erase this one. Let us check these 4. We have, if they ask you question types of fluid, you can also include that 5th one, ideal plastic fluid. But okay, let's discuss this 4. You can state them. We have ideal fluid, we have a real fluid, we have a Newtonian fluid, we have a non-Newtonian fluid. Then remember, the question can come and say define ideal fluid. What is an ideal fluid? Let us define. We check now. Let us define or state or define or what are the ideal fluids. Let us now define them. Okay, I can say A there. Can say ideal fluid. How can we identify ideal fluid? Ideal fluid, a fluid which is incompressible and which viscosity is 0. The ideal, it's a fluid. It is a fluid, right? Ideal fluid is a fluid which is incompressible and in which what viscosity. This one they don't have viscosity. In which viscosity is equal to 0. Yeah, it is equal to 0. You understand? Ideal fluid are fluid which are incompressible and in which viscosity is 0. Viscosity is 0, right? Are incompressible, right? Fluids which are incompressible and in which viscosity is 0. What is important? They are incompressible, and viscosity of them is equal to 0. We are done now. Let's check let me say P. Let's check this one. We are done with this one. Let's check this one. Real fluid. Real fluid. This one, a real fluid. A real fluid is a fluid which the fluid which is also is incompressible, right? Is incompressible and in which viscosity is present. That means viscosity is not equal to 0. Yeah, viscosity is not equal to 0. It is present. The difference here, ideal fluid viscosity is equal to what? To 0. This one, viscosity is present, is not equal to 0. It has a certain number, it's present. That's the difference between ideal and fluid. Also, incompressible, also this one, but they do have what? Viscosity. This one, they don't have what? Viscosity is equal to 0. They offer a little. Right, now let us check. Let me say C, which is what? Now let's check Newtonian fluids. Now let us check Newtonian fluid. Newtonian fluid, I can say it is a fluid in which shear stress is directly proportional to the velocity gradient, right? I can say this is a fluid in which the shear stress is directly proportional to the velocity gradient. Newtonian fluid, a fluid in which shear stress is directly proportional to the velocity gradient. You understand? Velocity gradient. There, let's check the last one, which is non-Newtonian. Here, let me say D. Let's check this one, the non-Newtonian fluid. Non-Newtonian fluid, this one, a fluid in which a shear stress is not directly proportional to the rate of shear stress. This one is not. This is directly proportional to the, can say, to the velocity gradient. This one, a fluid which I can say this is a fluid in which shear stress, let me say shear stress, yeah, You can say shear stress, not shear strain. Shear stress is not directly proportional to the rate of shear strain, right? Good. Non-Newtonian fluids are fluids which shear stress is not directly proportional to the rate of shear strain. Ideal fluid are fluid which is incompressible and in which viscosity is zero. Real fluids are like e.g. this one, like water. If you have water incompressible, let's say you pour water. I want you to make an experiment. Take your water there. Okay, I can say sewage. It's up to you. Take what? Let's say sewage. Let me, like this. You close this hole there. Let's say you close, you put your finger here, you close, you pour water until here. Let's say you've poured water here, there's water here. Right. When you compress, you apply the force. When you apply the force with your finger, you press that syringe. Here you have closed, then you press it. You will see what will happen. Okay, you will come there and press it. You'll see will never be your finger, this thing will move until here, this plate of a syringe will move until this position, will never go to this position. Why? It's because water is incompressible. If you have a 2 liter of water, then you squeeze the bottle. You squeeze this bottle like this. This is 2 liter, and you pour 2 liter of water full to this bottle. When you try to compress it, will never be compressed. Even if you release that water, you'll still have 2 liter. It cannot be compressed. It's incompressible. You cannot compress real fluids. Then they also like like real fluid, but you can compress and not incompressible. But fluid like gas is compressible. You cannot compress water. Otherwise, you cannot compress water. Right. Okay, guys. Subscribe to my channel. Feel free to like and comment. Not forget to subscribe and share this video to your fellow classmate. All the best. Stay tuned to the next comment session. We'll be dealing with the intro of calculation viscosity. We'll deal how do we calculate viscosity and stuff when we're applying in real life situation, or when we're applying solving problems. Then after we are done with the viscosity problem, we'll go to the surface tension. We'll deal with surface tension. Okay guys, sharp.